Hey, what's up guys? This is Guy here with KBTrainings. Welcome to this course on the CCNA 200-301. Today we are starting the section number 3, in which we will be talking about IP connectivity. And this is from, let me show you the blueprint here. So we are here 3.0. This is the IP connectivity section. So Cisco is asking us to learn all of this that is listed here. And that is what we are going to do in this section. So by the end of this, you will have a good understanding on IP connectivity, IP routing, and everything IP. I mean, not everything, because this is just the beginning of it. There are many notions that we are going to cover here on the CCNA, but many other notions will not be at this level because they are a little advanced. So this is the first chapter, the 3.1. In this chapter, we're going to cover IP routing concepts. I will tell you all the different concepts that you have to know to start, not every concept of IP routing, but all the main core concepts that we have to know in order to be good in routing and be good for the CCNA. But of course, I go a little bit beyond the CCNA because that's how I like to do it. Because when you are just limiting yourself to those basic things or to whatever the CCNA is requiring, you might have some trouble understanding some other notions. So I really prefer to go a little further to give you some better understanding on some topics. So this is a chapter 3.1, and the first lesson, which is the lesson 3.1.1, we're going to cover the IP routing process in general. This is an overview of the travel or the journey of an IP packet from the source to the destination, or from the origin to the destination. This is going to give you just an idea of what we will be able to accomplish after we are done learning this whole section, and exactly how the router and all the devices involved will make a decision to bring a packet to its destination. So to start, what is IP routing? IP routing is this process of guiding or redirecting an IP packet, which actually are the constituent of the data. So the data that you are transmitting on your network will be just IP packets that are being moved from the origin to the destination. So the process of moving those packets from one network to another network is called IP routing, because a route needs to be found between the origin and the destination. And of course, those two hosts are in two different networks. That's why we're talking about routing here. If they are in the same network, we wouldn't be talking about routing. That would be just a simple switching from one host to another host inside the same network. But we are talking about routing here because one host is in a certain network and the second host is in a very different network. And those two networks can be next to each other, or they can be far apart. They can be in two different cities or two different continents. The process will still work using all the rules, all the protocols, and all the technologies that are put in place to help us route IP packets. And that is the whole objective of this section. We're going to learn all of that. So I talked about the two networks being next to each other, just like in the LAN. You may have networks that are next to each other inside a local area network, or you have several networks all together, like in a WAN or the internet, which is the network of networks. So I have a packet transfer topology here, which we're going to refer to most of the time. And inside the topology, I just have a representation of, let me show it to you here, of a LAN. This is a local area network. And this is a wide area network, or WAN. This is going from city A to city B, from host A to host B in a different network far away. And in this example, I have just two networks that are connected to the same router. This router is connected to the network 192.168.0.0/24, and this interface is also of the same router, of course, is connected to the network number 10.0.0.0/8. So these are two different networks inside a same local area network, just like I have it in my house here. If you watch my video on YouTube, I have my home network, for example, that is here, and I have another network which is a lab network. So they're all connected to the firewall, and the firewall or the router will be routing the traffic between the home network and the lab network. So we're going to just do an overview of all of that very soon. But before we move forward, let me see some of the terms that we're going to cover here. So we're going to, of course, talk about LAN, how you route traffic inside the lane. And we will see the whole aspect of the packet. So we'll see the whole aspect of the journey of the packet. So we talk about the IP address, the MAC address, and how do you use these two information to, of course, send your packets. And then we talk about different networks, subnet. I just put these words down so I can say a little bit of something on all of these words or notions that we have here. But yeah, let me just bring packet tracer again, and I'm going to explain it to you with a little bit more detail. So we all know the IP address, okay? We saw that lesson on IP address. It's this 32-bit for the version 4 or 128-bit for the version 6. This is the number that identifies a host inside a network, okay? That same host has also what is called the MAC address, which is the physical address of the network interface card that is used by by the host to communicate with the network. So these are the two pieces of information that a host need to be able to send a packet to another host. So if I'm here, for example, on the PC0 and I want to send packet to PC4, I need its IP address. I also need its MAC address. The IP address is known by the application or by the user, but the MAC address is not known. So when I have a packet that I want to send from here, the first thing that I'm going to do, the computer or the host, the PC0, the first thing that I'm going to do is ask myself, is this destination inside my network or outside in a different network? And to that question, we have one of these two answers. The first one is that the computer might be inside my network, like inside my VLAN. If it's inside my network, I can reach the device directly without any other device in the middle. So if I'm here, like this is 10.0.0.2, and I want to send traffic to 10.0.0.3, there is just the switch. Actually, the switch doesn't do much. The switch will just take my packet and then redirect the same packet to the destination. But the second option can be that the destination is in a different network. That is where there is a notion of default gateway. The default gateway is a device, usually a router. It's a device to which every host will send the traffic if that traffic belongs to a host that is in a different network. In our case here, the default gateway is this router that we have. This is going to be our default gateway. You can see the IP. The IP is going to be 10.0.0.1. I put the 1 here if you can see it. So this is the IP that is on this interface. And this interface is the default router, the default gateway for these two devices here that are in this network. And if we open one of these, like if you go inside PC0, you can see under IP configuration, you can see that we have, of course, first of all, the IP address, and we have the subnet mask. Oh, I haven't talked about this yet, but you might have an idea on what it is from the introduction. So the subnet mask is this information that will help you identify which portion of your address is the network and which portion is the host itself. Like here we have 10.0.0.0/8. There's no point here, /8. This 8 means that the first 8 bit on this address represent the network, and the last 16 bit will represent the host inside that network. So this is what the subnet mask is. The 255 will mean that 10 is the network, and the other bits after that will be the host. So if we have a computer that, let's say 10.0.0.2 and 10.0.0.3, these are in the same network because they have the same network portion, 10.10. If we have 10 and 11/8, these are in two different networks. So that's how you detect that. So you can see here that we have the subnet mask. Of course, we also have the default gateway, which is the IP of this interface here. So this is a router, the default gateway, and this router is supposed to know where are all the other networks. So that's why if this computer has a packet to send to the PC5 192.168.0.2, it's going to know, oh, okay, this is not inside my network and this is outside of my network, so I need to send this to the default gateway. So see what happens. It's going to do the ARP. to get the MAC address of the next hop. In this case, the MAC address will not be the MAC address of the destination, but it's going to be the MAC address of the default gateway. So it's going to send an ARP request to get the MAC address of the default gateway, and it's going to respond with its MAC address. So this computer will build a new packet with the IP address of the final destination, which is 192, and the MAC address of the default gateway, because that is the next hop in line, the next hop to which it's sending the traffic for it to go to the destination. So I just want to stress on that difference here. So if we are not routing, if I'm here sending the packet to my neighbor that is inside my same network, the ARP request will give me the MAC address of that destination. But if the destination is outside of my network, I'm going to get the MAC address of my default gateway, so that the default gateway will get the packet and will forward it to whatever destination. So in this case, I get the MAC address of the default gateway, and then I build my packet and I send it to the default gateway. When it gets it, the first thing it's going to do is check the routing table to see if it knows the destination network. And in our case, both those networks are connected to the same router, so the router will definitely know where the destination is. And we have many ways for a router to know the destination. Let me also talk about that here. And I can say we have three main ways. First of all, that destination can be directly connected. In our example, we have the 10 network and the 192 network. They are both connected to the same router. So the router knows that I have 192 on one end and I have 10 on the other end. When it receives the traffic from 10 to 192, it's going to send it to 192 without any problem. So what if the 192 is far away or is not directly connected? We can configure the route statically, which is called static routing. Static routing means you statically show your router where is the destination, or you configure many networks and you tell it, hey, this is the route you need to take to get to another network. Let's go back to packet tracer. I'm going to show you that. So if we have, for example, this network, this is a WAN, as I said, wide area network. So we have a user here who wants to access a server over there, but the server is very far away. What we can do with static routing is go into every router in this network to tell it where is this network here, where is the 172. But actually, I mean, I'm going a little bit in detail here. In this case, for a web server, what we're going to advertise is going to be this interface IP, and we're going to do port forwarding to get to the web server inside, but that's not something we want to cover here. We can go in each router to say, for example, if you have traffic for 20.90.0.2, at this point, send it to the router number 2. And then we go in router number 2, we statically say, if you have some traffic for this, send it to this. And you can clearly see that this is a very hard task if you want to configure statically every router. You can do it when you are at this step. For example, you can say, hey, this is the router to which you send all your traffic, and it's going to use that all the time. Or you can point these two and say, you can send it here, but if this is not available, you send it there. But there is also a third way of knowing that, is dynamically. We call it dynamic routing. This is the process where we use some protocols that are well known, like EIGRP or OSPF or RIP or BGP. These are called routing protocols. These protocols will help the routers exchange their routing table. Oh, actually, there's a new word there, routing table. What is a routing table? A routing table is just a table inside a router in which the router will put all the network that it knows and how to reach those networks. For example, if we go back to this router here, we can clearly see that when you open it and you run a command like show IP routes, this will show you the two networks that this router is aware of. we can see that we have the network 10.0.0.0/8 and 192.0.0.0/24. So these are two networks that are directly connected to this router. You can see it's directly connected, and we also have the interfaces. We have the interfaces here. So this is a routing table. This router is capable to take this routing table and send it to many other routers around the world or inside the company, to let them know what route or what network the router is connected to. And that is dynamic routing. And it can be done using a protocol called the routing protocol. Like in this example, we have our network here, our interface 20.90.0.2/16. This router can advertise this network to all the different routers, and all the routers will have this network inside the routing table. So when a packet comes over here, this router will have to decide, hey, where do I send this traffic? Do I know where this network resides? And then it will make a decision and send it one way or the other. So when it goes to the next hop, it will also make the same decision. Do I know where it is? If it doesn't know, it's going to drop that traffic. It's going to create what is called a black hole. So that traffic will not go anywhere, because it left there. Then when it got to the first hop, the hop knew where to send it. When it got to the second hop didn't know, and then it would drop it, which also can happen if you have some misconfiguration. But in a normal instance, you have your packet here, and you make the same decision, and then you send it to the next hop, and then you finally reach your destination. This one will get let's say the web request, and we'll forward the web request to the web server, and then the response will come back, and it's going to be the exact same process. So that is called dynamic routing. You can also have static routing, where you statically show to the router where the next hop is for a certain network. We talked about the default gateway for a host. There's also what is called the default route. The default route is the route that you show to a router to send every traffic for which it doesn't know the destination. So if there is a traffic coming for a certain network and your router doesn't know where the network is, you can have a default route. Like for example, if we are connected, this is a company, and we are, let me clean this up. So let's say this is a company and we are connected to our ISP. So this is our router and the ISP is here. We can have a default route set in this router to say, hey, this is your uplink router. Everything that you have, if you don't have that network connected to you, send it here. That is the default route. It's also something that we're going to cover. This is just an overview. We're going to go deeper into all these notions inside this IP connectivity section. And at the end of it, you as an engineer, you as a CCNA certified, you should be able to configure for a packet to leave here, which is the A side or the origin side, to the Z side, which is the destination. And of course, all these other routers in the path will be the B, C, D, and so on. This is just how we can illustrate that. So we'll have different hops in our path to bring our IP packet to its destination. So as you can see, there is a lot to say here, but the principle is pretty much simple. Bring an IP packet from the A point to the Z point. So the A and the Z points might be next to each other, or the A and the Z point might be far away, might be in two different continents, or two different countries, or two different cities. So that's what we're going to learn here. All those notions that I mentioned, the routing table, the default gateway, the default route, the static routing, dynamic routing, we're going to learn all of that. And by the end of this section, you'll be able to configure everything and build your own very big topology with different routers. So in the CCNA exam, we are only required to know OSPF, which is one of the routing protocols. All the other ones, you will learn them when you go up in your certification. But for now, we're going to focus on OSPF and all the other notions that I mentioned here. All right, so that's it for this lesson, in which I showed you the journey of a packet leaving a host to for a different host in a different network, and how the packet will be formed by each node or by each equipment in the path to the destination. And again, the MAC address will be changed to only include the MAC address of the next hop in the path, but the destination IP will still be the final destination IP inside the packet. So I'll leave you a link here for more reading. You can get some more information there. But this is just the beginning of this section. Take your time to watch every lesson here, and at the end, we will be comfortable with IP connectivity, and it won't have any secret for you, at least for the CCNA level. All right. Thank you for watching this, and I'll see you in the next lesson. Bye.